All right. So nuclear physics. Nuclear physics, as you can see in this page in your textbook, it shows the sun, the blazing, flaming, hot sun. Okay. So actually the sun is where the source, a lot of the source of radioactivity is happening at the sun, because the sun, as we all know, have a very, very high temperature. So the high temperature provides a very good factor in helping the radioactivity process to happen. Okay, so you are going to learn about that later on. Okay, so in Form 3, I will show you what you have learned in the Form 3, the basics for this nuclear physics. So earlier this morning, this is what I have taught in the Form 3 lah, earlier this morning. Okay, so this is from Chapter 8 in Science Form 3. Okay, Chapter 8 in Science Form 3, you have learned about this. And basically what you have learned in Form 3 is some of the history of radioactivity, some of the earlier discovery of radioactivity that involves like Wilhelm Röntgen, discovery of X-rays, and then Pierre and Marie Curie. Okay, this is the couple, Pierre and Marie Curie, that also discovered two radioactive elements, polonium and also radium. And also this one, Henri Becquerel, bukan Henry, Henri Becquerel, right? So he's a French physicist, and he was the first person to successfully discover radioactivity, right? And then you have also learned about this one, the 3 types of radioactive radiation, namely alpha, and involving alpha particle, beta particle, and also gamma ray. Okay, so alpha and beta is a particle and gamma is a type of ray, right? So we will be revising that again. So radioactive decay also you have learned, involving some of these radioactive elements in the periodic table. Okay, and then units for radioactivity. There are 2 types of units of radioactivity. The first one is Curie, CI, and also the other one is Becquerel, symbol BQ. Okay, so those are the 2 units involved in radioactivity. Okay, and then you have also learned in Form 3 about half-life. Half-life ataupun separuh hayat lah. Now, this is quite simple. The concept of half-life is just as long as you know how to divide by 2 or times 2, then it's easier to get the answer for the calculation. Okay, bahagi 2 sahaja, bahagi 2 kali 2. Okay, that is the concept. Okay, and then you have also learned some of the methods to determine half-life. First one is by calculation. The second one is by using methods of graph. And what else? Okay, we have also some calculation involving percentage and also mass. Okay, we'll be revising that later on again. And also this one, atom and nucleus. You have also learned this in your chemistry also, and you will be learning this again in your physics, right? So structure of atom. In the middle is the nucleus, which consists of the proton and also neutron. And as you all know, the proton is positively charged particle, and the neutron is a neutral particle, which is not charged. And outside the nucleus is the electron, which orbits the nucleus. And the electron is a negatively charged particle. Okay, so those are some of the basics lah, structure of atom. And also you have learned about how to form positive ion or cation and also negative ion or anion. Okay, so positive ion is by losing electron and negative ion is by gaining an electron. So negative ion is anion. Okay, and then ionizing radiation and non-ionizing radiation. Also, you have learned in Form 3. These are some of the basics that you have learned. Again, you need to remember back the electromagnetic spectrum, gaya ekstrim untuk Valentine ialah minum racun. Okay, so those are included in the non-ionizing radiation and also ionizing radiation. Okay, and then this one also, types of ionizing radiation involving the alpha radiation, beta radiation, and gamma radiation, gamma ray. Okay, the comparison between these three types of radiation. We will go into that again. Okay, and then sources of ionizing radiation. Okay, itu simple sajalah. So those are some of the basics that you have learned in your science form 3. Right. In form 5, as you can see here, these are some of the things that you will be learning. What is radioactive decay? What is half-life? How can the uranium decay series be used to determine the age of rocks and Earth? What is meant by nuclear fission and nuclear fusion? Okay, so this one is a new concept that you will be learning about nuclear fission and nuclear fusion. So it all relates to the sun in this page that you are looking at. What is the relationship between nuclear energy and mass defect? Okay, nuclear energy symbol is E, mass defect symbol is M. So it will all point to the Einstein formula, which is E equals to mc square, the famous equation of Einstein. And E doesn't stand for Einstein, it stands for energy. Specifically, we are referring to nuclear energy. And lastly, is it feasible to build a nuclear power plant in Malaysia? Yeah, so we will all go into that. Okay, so as you can see here, there are only 2 subtopics in this chapter, short one. Okay, so I hope that you are able to answer the questions from this chapter dengan senang lah. So it is not that hard. It's just that you need to do a lot of reading. Okay, so we'll start here by 6.1, radioactive decay, or NBM, perebutan radioactive. So radioactive decay is a process. Okay, so like I said before, if in paper 2, the question usually asks, the first question that they usually ask will be the definition of a concept. So some radioactive decay. Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiation. Okay, so that is the proper definition for radioactive decay. A process in which an unstable nucleus becomes more stable by emitting radioactive radiation. This process is random and spontaneous. Random because we don't know which nucleus will decay, and it also happens spontaneously, secara spontan. Tiba-tiba saja. We don't know which nucleus will decay, and we don't know when will it happen. Okay, so that is meant by random process and spontaneous process. So there are 3 types of radioactive radiation, namely alpha particle. So you have to know how to write the symbol for alpha, beta particle, and also gamma ray. Gamma ray. Now alpha and beta is a particle, but gamma is a ray. Okay, alpha and beta is a particle which has a charge. Alpha positively charged, beta is negatively charged. But gamma is a ray. Dia hanyalah sinar. It is not a particle. It is not a particle, so it doesn't have any charge. It is a neutral. All right, neutral. And then for alpha particle, as you can see here, the alpha particle is actually the helium nucleus. Helium nucleus. Helium nucleus. What is the atom number for helium? Now for this one, you have to refer back to the periodic table. Periodic table, okay, hold on, try to find back where is the periodic table again. Okay, so this is the periodic table. Helium, okay, this is helium, okay. At the upper right corner is the helium. Atom number is 2. Nuclear number is 4. So helium is written as He42. Tuh kan? Correct? Helium. What does it means if I write the element number like that? He42. How many protons does the helium nucleus have? How many protons, how many electrons, and how many neutrons does it have? Anyone can tell me? How many protons, how many electrons, and how many neutrons? Dua. Okay, 2 protons. And usually a nucleus is neutral. So if you say that it has 2 protons, so the number of electrons will be the same. So it also have 2 electrons. And then the neutron, you can find the total number of neutron by subtracting from the nuclear number. So 4 minus 2, the neutron number will be also 2. Okay. 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 Now, the blue one is the proton. The blue one is the proton. Ini. This is the proton. So helium 42. Proton 2. Electron will be 2. So neutron will also be 2. Okay. Now for beta particle has the same characteristics as an electron. So the gray sphere that is shown is the electron, and the electron is negatively charged. So small size, it can travel quite fast compared to the helium nucleus, which is very heavy because it consists of 2 protons and 2 neutrons, right? And the gamma ray is just a ray. Dia hanyalah adalah sinar. Okay. Only a ray. So it can travel very, very fast. In fact, it can travel with the speed of light. Speed of light is c equals to 3 times 10 to the power of 8 meter per second. Because it is not a particle, it is a ray, so it can travel very, very fast. Okay, so that's the basic of that one. Now, for equation for alpha decay. Equation for alpha decay. Alpha particle is a helium nucleus. Helium nucleus, which consists of 2 protons and 2 neutrons, like what I have said just now. 2 protons and 2 neutrons. 2p, 2n. During alpha decay, an unstable nucleus releases an alpha particle to become a more stable nucleus of a new element. So this is an example of how alpha decay happens. So basically, it will start from a parent nucleus. A parent nucleus, we represent the unknown element by using X. Okay, so we assume that one is the parent nucleus. So A stands for, what is A? A is the nucleon number and Z is the proton number. Okay, A is the nucleon number. Nucleon number consists of protons and also neutron, and Z is the proton number. Okay, so when it decays, when alpha decay happens, it will release an alpha particle. An alpha particle is in the form of a helium nucleus. Okay, so that's why in the equation you will have to write this one. So when the element, the parent nucleus, decays, it will become a new element, okay, a new element, and also releasing an alpha particle. So that alpha particle is the one that is radioactive. So basically, what will happen is the nucleon number will decrease by 4 and the proton number will decrease by 2. Okay, so let's look at this example here. Polonium, PO. PO is polonium. So when it decays, polonium decays, so the nucleon number will decrease by 4 and the atom number or the proton number will decrease by 2. So 210 you minus by 4, you will get 206, and 84 you minus by 2, you will get 82. So to balance the equation both on the left hand side and also on the right hand side, both of the total numbers will have to be equal. So in this case, the total number on the left hand side is 210 and also 84. And then on the right hand side, the total should also be the same. The sum of the numbers should also be the same. 82 you plus with 2. Okay? Can you understand this one? The characteristics for alpha decay, it has to include the helium nucleus because this is the identification for alpha decay, the helium nucleus. Okay, so you have to include that one in the equation. Okay, thank you, Anya. Okay, so moving on to the next one, beta decay. This beta decay involves electron. So beta particle is a fast moving electron. Okay, so beta particle is a fast moving electron. So during beta decay, a neutron in an unstable nucleus decomposes into 1 proton and 1 electron. All right, so it starts from a neutron. As we all know, neutron is neutral. So that's why this is the charge for the neutron, 0. 0 means the neutron doesn't have any charge, but the mass is the same like the proton, 1. So when it decays, the proton number will increase by 1. So as you can see here, it will produce 1 proton and also 1 electron. And also the sum of all the numbers also have to be equal both on the left hand side and also on the right hand side. Okay, dia mesti equal lah, dia punya total itu mesti equal. So this one 1 minus 1 equals to 0. Macam yang di atas tu pun sama juga lah, 1 plus 0 equals to 1. So the important thing is, for beta radiation, you have to include this one. This is the identity for beta radiation. Beta radiation, you must include the electron in the equation to show that it is a beta radiation. Alpha radiation just now, you have to include helium nucleus, and for beta radiation, you have to include electron. Now, example of equation for beta decay is like this one. Okay. So the same thing lah kan, dia mesti include yang electron. Example here, sodium Na2411. So when it decays, the proton number will increase by 1, and it will release a beta radiation to become magnesium, and release a beta radiation in the form of an electron. So both of the numbers on the left hand side and on the right hand side also must be equal, right? So that is the example for beta decay. And thirdly, for gamma decay. Gamma decay, the symbol for gamma decay is, you can write it like this one. Macam huruf Y lah. Macam juga itu, how you say the zodiac-nya sign itu? Taurus kah? Okay, gamma rays are high frequency electromagnetic wave. High frequency electromagnetic wave. So remember back the electromagnetic spectrum, we have gaya ekstrim untuk Valentine ialah minum racun. So G stands for gamma, which has the highest frequency. So high frequency means that it has very, very high energy. So during gamma decay, an unstable nucleus releases its excess energy to become more stable. Gamma rays have no mass and neutral. Neutral means it doesn't have any charge. So the general equation for gamma decay is like this one. It is still the same element. It is still the same element after it decays, but it will become more stable. Become more stable because it has released the gamma radiation. Right? Okay, so example of gamma decay is involving this one, cobalt. Cobalt, so after it decays, it is still a cobalt element, but it has become more stable by releasing the gamma radiation, gamma ray. Okay, so that so all of that is the example for gamma radiation. Okay, so during a radioactive decay, some nuclei means the plural for nucleus. Singular is nucleus. So nuclei is the plural. Can emit more than one radiation. For example, during the disintegration of uranium-234, its nucleus emits alpha particle and gamma ray. Example of its decay equation and a simpler decay equation are as follows. So this is example of the equation, uranium. So when the uranium decays, it will become thorium. Okay, thorium, and also will release alpha radiation and also gamma ray. How do you identify whether it is alpha, beta, or gamma? It all depends on the element or the particle being released. So this one is the identity for alpha radiation. This one is for gamma, right? So it can happen It can include either one type of radiation or two types of radiation. So this is also another way to write the equation by including the types of radiation involved. Okay, so we have just now is the alpha and also the gamma radiation. For the uranium element to become stable and become a thorium element by releasing alpha radiation and also gamma ray, right? This one okay?
Okay, teacher.
Okay, moving on to the next page. Okay, half-life. Half-life, bahagi dua kan? Like what I have said, bahagi dua, you have learned this in Form 3. Half-life, and the symbol for half-life is, we use it capital T and then subscript half. Okay, capital T and then subscript half. T means the period, time. When a sample of radioactive material decays, the number of parent nuclei which has not decayed decreases with time, while the number of daughter nuclei increases. So ini just an activity. So I just go straight to the calculation lah. Half-life, so like I said just now, this is the symbol for half-life, is the time taken. Okay, so this is another definition for you to remember. The half-life is the time taken for a sample of radioactive decay to nuclei to decay to half of its initial number. Okay, time taken for a sample of radioactive nuclei to decay to half of its initial number. After one half-life, the number of nuclei that are not decayed will be half. So it's always half of its initial value. When an unstable radioactive nucleus decays, the new nucleus that is formed may also be unstable. The new nucleus will experience a series of continuous decay until a stable nucleus is formed. So figure 6.5 shows a complete decay series from uranium-238 to become lead-206. So uranium symbol is U, lead is plumbum, Pb, and their respective half-life. So as you can see here, okay, let's check again in the periodic table, where is the position of the uranium and also lead in the periodic table. Uranium and lead. So this is where uranium is. This is where uranium is. Okay. Ini ya. This is uranium. And then it will decay, undergo a series of decay to become stable and become lead. Okay. The atom number for uranium is 92. As you can see here, the atom number of uranium is 92 and the atom number for plumbum or lead is 82. Okay, so that's the in the position in the periodic table. Now let's see. One half-life of the uranium nucleus, okay, will to become thorium, it will take about 4.5 times 10 to the power of 9 years, which is very, very long. Okay, it is very, very long. So after it has become a thorium element, and then it will decay again because it is still unstable. it will decay again to become Pa, what else? Uranium, and so forth and so forth. It takes quite a number of series for it to decay, and then lastly it will become a lead 206 to be stable. Okay, so this is just an example. For the calculation, later on we will try and do the calculation. Okay, uranium 238 is a radioactive element with a long half-life. That is about 5,000 million years. This element is trapped during the formation of rocks. The trapped uranium 238 will decay and eventually form a stable lead 206 as shown in figure 6.6. This decay process takes a long time because the decay rate is low. By determining the ratio of lead 206 to uranium 238 in a rock, the age of the rock can be estimated. The higher the ratio, the older the rock. This geological method of measurement can also estimate the age of our Earth. Okay, so this is what the scientists use, the method they use to determine the age of our Earth. And our Earth is, I think it's very old lah kan. Bukannya, I'm not really sure about the exact figure of the age of our Earth. Maybe you can Google it later. So these are some of the methods that are used to determine the age of our Earth. Right. How to determine the half-life of a radioactive substance from its decay curve. So radioactive substance will experience random and spontaneous radioactive decay. The number of nuclei which has not disintegrated decreases with time. Different radioactive substances decay at different rates. A decay rate can be determined from a decay curve. So let's check again. This is the activity, but I don't think we have to do that one. I just go straight away to the calculation. This one, okay. Okay. So according to this table here, the initial condition, this is the initial condition and not initial condition or initial number of the activities. So after one half-life, the number will decrease by will decrease by half. So half, so you put half in front. After another half-life, so you have to divide by 2 again. So 1/2 you divide by 2, you will get 1/4. Third half-life, you divide by 2 again, so you will get 1/8. Another half-life, you divide by 2, so it will become 1/16, and so forth. So you will get that number. So to calculate the number of decayed radioactive nuclei, so you have to subtract from the initial value. Ini senang saja banget, mathematics, you just subtract from 1. Tolak daripada 1 sahaja to get the remaining number of decayed radioactive nuclei. So that is how you determine dia punya number. So this is the curve graph for radioactive decay. Curve graph for radioactive decay. So it looks like this. So it will start with the initial value. There is a y-intercept here, which shows the initial value of the activity. So after one half-life, this is one half-life, T half. So the number of activities will be reduced by half. And then another half-life, it will be reduced to half again to this value. And then so forth lah, dan seterusnya. Very easy to read from the graph. It's very easy. No need to worry. Okay, so by looking at this graph here, the orange curve and also the green curve. So by comparing these two curve graph, we can see that the green curve showed lower decay rate, and the orange curve shows higher decay rate. It means that it will take a shorter time for it to decay by half compared to the green curve lah. It takes a slightly longer time for it to decay by half, right? So that is how you compare and you describe the curve graph there. Right, for the calculation involving half-life, so this is an example. A sample of radioactive material stored in the lab has an initial activity of 480 per second. So this is the initial value, 480 per second. If its half-life is 6 minutes, this one is the half-life. How much is it? How much is its activity after 30 minutes? So if one half-life is 6 minutes, one half-life is 6 minutes. So 30 minutes is how many half-life? Berapa banyak tuh dia punya half-life? If one half-life is equals to 6 minutes, so 30 minutes is how many half-life? 5. Yes, correct. So you put there 5 half-life. So means that you have to divide the activity 5 times. So we start from 480. Okay, so we start from this value 480. Okay, it will decay. This is one half-life. So half of 480 is 240. Ingat, kita mau bahagi 2 saja. Another half-life, so half of 240 is 120. Another half-life, half of 120 is 60. Another half-life, half of 60 is 30. And then last one, another half-life, so half of 30 is 15. So mesti ada 5 times kan? 5 times half-life. 1, 2, 3, 4, 5. 5. So the question is, how much is its activity after 30 minutes? So the answer would be 15 per second. 15 per second. Okay, just like this one. 15 per second. Do you understand how to do that one? Ken? Okay, paham? How to get the number? Okay ya. So mesti pandai bahagi 2. Yes, Anya? Any problem? Ya, practice bahagi 2 saja. Belajar bahagi 2. Okay, we try and do the second one. This one is involving percentage. This one is involving percentage. Just remember that the full value of percentage is always 100%, kan? 100%. So a radioactive material stored in the lab has a half-life of 10 days. Okay, half-life there adalah 10 days. So this one, we put the symbol for half-life. Calculate the number of days taken for the activity of a sample of radioactive material to reduce to 25% of its initial activity. So in order to determine the answer. So we can determine first lah how many half-life does it takes to reduce to 25%. So again, we start from 100%, which is the full value of the percentage. So half of 100% is 50%. That is one half-life. Okay, one half-life, which is equals to 10 days. Okay, and then after you have divided by 2, then you will get 25%, which is another half-life and also another 10 days. So the number of days taken will be 20 days. So therefore, after 20 days, activity of the remaining radioactive material is 25% of its initial activity. So this is the second example. So okay, we will do the practice questions later. Okay, so this one again is by using a ratio. Using ratio. Ratio of nuclei of argon-40 to potassium-40 in a sample of volcanic rocks is 3 to 1. 3 to 1. In the early formation of the rocks, there was no argon element trapped in it. If potassium-40 decays to argon-40 with a half-life of 1,250 million years, estimate the age of the rocks. This one is the half-life. So how do we do this question? This is very hot question lah. Hot question. Previously in the KBSM syllabus, this type of question never been asked by using ratio. Okay. So judging from the calculation in the table, which is quite confusing. How am I going to explain this one? I do it like this one. The total number for the ratio, if you add it, is 3 plus 1, 4, kan? Ratio that 3 plus 1 equals to 4. So this one is 3 over 4. This one is 1 over 4. Kan? 1 over 4 and also 3 over 4. And then how to get from 1 to 3 over 4. Ada berapa kali itu dia punya half-life itu to get from 1 kepada 3 over 4. How many half-life does it takes? So one half-life, we start from 1. One half-life, you divide by 2 is 1 over 2, correct? And then if you do another half-life, you divide by 2, it will become 1 over 4. So this one, 1 over 4, dia corresponds to this one, 1 over 4. Kan? So, but we compare to the initial value, the remaining number of argon-40 nuclei form. So you minus from 1. 1 minus 1 over 4, it will be equals to 3 over 4. This one, 3 over 4. So dia apa tu? Tally with the ratio 3 to 1. So it means that it has undergone 2 half-life. So 2 half-life you times with the value of the half-life, 1,250 million years. So you will get 2,500 million years. That is the age of the rock. So maybe we can do another practice question. Mana satu? Okay. Question number 3. Question number 3. We try to determine what is the half-life of the radioactive sample. But this one, yang number 3 ini, if you divide it by 2, hold on. So you start from 1,520. If you divide it by 2, what is the value if you divide it by 2? This equals to 760. Then you divide it again by 2, will become 380. Divide by 2 again. $190, and then you divide it again by 2, 90, 95. Okay, ini. This one, this one. So what is the answer for A? Determine the half-life of the radioactive sample. What is the half-life? Can you guess what is the half-life based on the calculation? How many days does it take? Is it 10 days or 5 days? Which one? 5 bahkan. Because the period from 10 January to 20 January is this one takes 10 days. From 20 January to 30 January also it takes 10 days. 10 days kan? So we can say that this one takes 5 days. This one also takes 5 days. And so does the rest of the decay. So it will all add to how many days? 20 days. Kan? So the value of the half-life that we are looking for is 5 days. Okay, so it can be shown by using yang calculation tu lah, divide by 2 sahaja. Yang B itu sketch a radioactive decay curve for the sample, so you have to draw based on this calculation. So you have to draw lah. So you start with this one. By using start here, value dia adalah berapa? 1500. 0. Then it will decrease 1 half-life, 2 half-life, 3, 4. So you will be able roughly like this one lah, right? Then you have to show what is the value lah. What is the value? 760. Another one, 380, 190, and then lastly sana tu 95. Okay, so this is roughly how you sketch the decay curve. Don't forget itu dia punya label. This one is for the activity, and this one is the time. Time is, don't forget to put dia punya unit because we are using days. Okay, so that is how you determine how to sketch dia punya half-life. Now we will continue to discuss this topic further on Friday. Boleh? Can?
Can, teacher.
Alright, so if you have no more question, then you can go. I'll see you again on Friday.
Okay, thank you, teacher.
Alright,
Thank you, teacher.
okay.